Lesson 10.4 is on triangles. I can classify, remember that means to name, triangles and find missing measures. You need to know this like the back of your hand. All triangles add up to 180 degrees. So it doesn't matter what triangle you have, all of the interior angles, which means those angles inside the triangle, add up to 180. So if I know that they add up to 180, I would say I'm going to add this plus this plus this, and I will get 180. So to work backwards, I can take what I have, so I have 140, and subtract it from what my total is, and I find my missing amount. So that tells me that this missing amount is 40 degrees, and that looks like it makes sense for that triangle. Looking at this triangle here, I know that it adds up to 180 degrees. I have 90 degrees and 25 degrees. You could take 180 minus 90 and then subtract 25 again. I like to add up what I have and then subtract just once because I like to add better than I like to subtract. So to me, I don't want to subtract twice. So remember that this symbol means 90 degrees. So 90 and 25 is 115. Subtract that. I need to borrow here. I have 65 degrees left over for here. You can always check these and say, does 65 plus 90 plus 25 equal 180? And it should every single time. All right, down here, this triangle, I have 20 degrees here, but these are questions. Now, if you notice, these are the same angle, and we're going to learn that this is an isosceles triangle, which tells us that these two angles should be equal, but it's showing with this symbol here. Since there's one line and one line on both sides, it's showing that those two are equal angles and that we can split that evenly. So if I have 180 degrees, take away what I see, I'm left with 160 degrees to split between two equally. If I'm splitting something between two equally, then I'm just going to divide it in half, and that gives me 80 degrees for both. Check it. Does that work? 80 plus 80 plus 20? It does equal 120. I'm sorry, 180. All right, and the last one, I have 76 and 42 together. 76 and 42. I'm going to add this one off to the side to make sure I don't make a mistake. Is 118. So I'm going to take 180, subtract 118. Again, I need to borrow. 62 degrees is left over, and I can check. Do those add up to 180? And they should. All right, I want you to pause the video and try these problems. Okay, did you find that this had a symbol here, which meant it's the same as that? So these two are both 64 degrees. And so if I take 64 plus 64, I get 188. Oops, sorry, 128. Going too fast. So I'm going to take my 180, subtract what I have, 128, borrow, and I get 52 degrees left for here. Remember that this symbol stands for 90, so when I put 90 and 40 together, I have 130 there. Take 180, subtract my 130, and I'm left with 50 degrees to go right here. All right, so triangles are classified in two ways. One by their angles and one by their side lengths. So if I was looking at these three triangles, they're all going to be called something different. Notice this one has a right angle, so we're going to call it a right triangle. It has one 90-degree angle. This second triangle here, all of these angles are acute, so we're going to call this an acute triangle, and all angles are less than 90 degrees. And this last one has an obtuse angle, so we're going to call it obtuse triangle. And one angle is more than 90 degrees. You are never going to have more than one right or obtuse angle in a triangle because it would add up to more than 180, and that just wouldn't work. We're going to skip this bottom part and move on. Okay, so triangles have a first name and triangles have a last name. They don't need to go in a first or last name order, but think of it as they have an angle name and they have a side name. We haven't talked about the side names yet. The angle names, your choices are acute, right, and obtuse. Acute, right, and obtuse. Your side names are going to be equilateral, which means all of the sides are equal. When you see these little lines like that, as long as they match, it means the side lengths match. So this is an equilateral triangle. This pen is not doing a good job there. Equilateral triangle. Okay. Then we have one that has two sides that are the same and one that's different. On these, those angles at the bottom are, I shouldn't say at the bottom, the ones that have the same side lengths when they come together at the bottom or wherever they come together, they're going to be equal as well. And this is isosceles. Isosceles. That's an E. Okay. And then the last one is a scalene. I like to think of it as like kind of a leaning triangle. That one's not super great, but each side is different. So see how they all have different little hash mark lines? So it's scalene. And it means that there are no sides that are equal. So let's go through and decide what the angle and the side names would be for each of these. So I notice that there's a 90-degree angle here, so I'm going to call this a right triangle. And all of the sides, it's very hard for me to tell on this one if they're equal or not. Since it doesn't have anything labeled, I'm going to assume these two look equal and this one looks different. I'm going to assume this one is an isosceles. In your homework, they're going to be a little bit more obvious than that. This second one, this is definitely an obtuse angle, so we're going to call it an obtuse triangle. And this is very easy to tell that all of these side lengths are different, so we're going to call that a scalene triangle. There are several more examples here. For this one, the angles, I don't see any right angles or any obtuse angles, which means it's an acute triangle. It looks like this side and this side are the same length, and this one's different, which is an isosceles triangle. All of these angles definitely look the same, or side lengths look the same. I'm going to name my side equilateral. Again, I don't see any 90-degree angles, and I don't see any obtuse angles, so this is again an acute triangle. Now, this last one, I like to kind of turn my head and look at it that way because it makes it easier to see that this is an isosceles triangle, and there are no right angles, and there are no obtuse angles, so this is an acute triangle, and it is isosceles. All right, this one looks like it's leaning. Remember scalene and lean? You can tell that these sides are all different lengths, so this is a scalene triangle. Do you see any right angles? I do not. Do you see any obtuse angles? This one looks a little bit obtuse. So there we go. It's an obtuse scalene triangle. The next one, it doesn't necessarily look like it's leaning. However, this side is definitely different than this side, which is different than this side. So all three of those sides are different lengths. I'm going to call this one a right triangle because I see a right angle there. And since they're all different lengths, it's a right scalene. And the last one, definitely all these sides look the same, so that's going to be an equilateral triangle. And definitely none of these are right, and none of them are obtuse, so that is an acute equilateral triangle. Sometimes you only get words to tell you about the triangle. So remember, the word congruent means the same size. So it says a triangle with 3 acute angles and no congruent sides. So a triangle with 3 acute angles, that means there are no right angles and no obtuse angles, so it's left with an acute triangle and no congruent sides, no sides that are the same. This one has 3 sides the same, this one has 2 sides the same, this one has no sides the same, so that would be an acute scalene triangle. The second one says a triangle with 1 obtuse angle and 2 congruent sides. So 1 obtuse would mean it's definitely an obtuse triangle, and 2 congruent sides. Isosceles triangles have 2 sides that are the same, which means congruent, so it would be an obtuse isosceles triangle. And then the last one, a triangle with 1 right angle and no congruent sides. Okay, so 1 right angle would definitely say it's a right triangle, and no congruent sides. That means all the sides are different. That would be a right scalene triangle. You're done.